This is a difficult past exam question about electrical circuits. Now, when approaching these questions, you always want to either think about using any of these equations, all of which are given to you in an exam, apart actually from these three equations. They're not given in some examples, so you can have a look at your specific equation sheet to check if they are given. Or you have to use the idea that in series current stays the same. This is how I used to remember it, and I used to remember that everything else is pretty much the opposite. So in series, the voltage is split up. In parallel, the current is split up. And when two components are in parallel, the voltage stays the same across both of them. Now let's have a go at using this. So there's a 25 ohm resistor in series with this whole junction here, which is in parallel. Now the resistance between terminals A and B is asking for the total resistance, which is the total resistance of this combination here. I mentioned this is in series with all of this, but we first need to find the resistance in this parallel combination and then add it on to this 25 ohm resistor. So in parallel, we use this equation. We say 1 over the resistance is 1 over the first resistor in parallel plus 1 over the second resistor in parallel. That will add up to 2 over 400, which is 1 over 200. And then after you find that, you do the reciprocal of both sides. So the resistance over 1, or just the resistance, is 200 over 1, or 200 ohms. So this component, this whole junction here has 200 ohms. And then because, like I mentioned, this whole thing is in series with this, we then use this equation for the series part of the question. You do 200 plus the 25 ohm resistor, and that will get you the total resistance of 225 ohms. Next, it says the potential difference applied between the terminals and the power that goes through each of these resistors is 1 watt. Let's label that on the diagram. This is, by the way, that more difficult part of this question, part B. And it's asking for the potential difference across both of the resistors. Now, what do we notice? They're in parallel, and in parallel, the potential difference is the same. Why that's important is if you find the potential difference across one of the resistors, that's the same as it is across this one and across both resistors in general. So we're going to focus on finding the voltage across one of the resistors. Because we're given the power through one of them, and we're also given the resistance across one of them, we can find the voltage using this equation here. Power equals V squared over R. So, sorry, my writing is going to be a little bit small, but we say that the power of 1 is equal to V squared, which in this case, oh sorry, I just lost my train of thought. That's what we're trying to find. Divided by the resistance of 400 ohms. Multiply both sides by 400. And then square root both sides. So the square root of 400 is just 20. And that's what the voltage is equal to across one of the resistors. And like I mentioned, they're in parallel, so it's the same across both of them. And that's the answer to this question. And now for the most difficult part of this question, part 2. Calculate the current through this resistor here. We have the resistance across this resistor, but one thing we don't have is the voltage across it. If we had the voltage, we could have easily used I equals V over R. I'm going to rub a few things out just so there's more space, because everything looks a little bit cluttered right now. Okay, so that tells you you can't use any of the equations to find the current across the 25 ohm resistor. So let's go back to this sort of table that I've drawn out. I mentioned before that this resistor is in series with this whole junction, meaning if we find the total current flowing through this parallel junction, that's the same as the total current flowing through this 25 ohm resistor. So let's focus on doing that, finding the current flowing through this junction. but there's more difficulty in this question, which is that the current, because these are in parallel, the current is split up. So what we have to do is find the individual current through this resistor, find the individual current through this resistor, which will be the same, by the way, because all the other values are the same, and add those together because the total current going in is split up across those two. So let's do that. We have, I'm going to change the pen color. Okay, so we have the power of 1 watt given to us. We also have the resistance of 400 for each resistor. You can find I by using P equals I squared R. So P over R would be I squared, just rearranging that equation. And you can square root both sides. There's more than one way of finding current here, by the way. I actually chose one of the difficult ways, but it's the square root of the power of, which is 1 over 400. And in the calculator, that'll get you 0.05 amps. We can do the same exact calculation here because the power across it is also 1 watt and the resistance across it is also 400 ohms. So the current across this resistor is also 0.05 amps, meaning the total current flowing into this junction is 0.05 plus 0.05, which is 0.1 amp, in order for it to be split up in this way. So the current flowing through the 25 ohm resistor is also 0.1 amps. Hopefully that made sense. This is definitely an A star level question, but if you have any questions, please let me know in the comments. Thanks for watching.